Hey, Algebra Studies, thanks so much for persevering through this with me. I really appreciate the work you guys are doing. Keep it up, you're doing awesome. I want to show you guys a few things on Desmos here just to introduce you to a few more concepts about parabolas. So I'm going to start by plotting the function y equals x squared. That's our parent function. Notice the points that it goes through, right? It goes through the point 0, 0. That's the origin, that's labeled, okay? There it is. And it also goes through some other easy points, like it goes through the point 1, 1. I'm going to label that one. And it goes through the point 2, 4. I'll label that one as well. And of course, we could keep going. It would go through 3, 9. It would go through 4, 16. I'm going to do some on the negative side as well. I'm going to do negative 1, 1, and we'll label that. And I'm going to do negative 2, 4, and we'll label that one as well. And now we have some points that are symmetric about the parabola. Okay, the really interesting, though, that I want to do here is I want to see how that parabola changes when we do things to the equation. So I'm going to leave what you see there just totally in place. I'm not going to mess with that at all, but I'm going to add one new function. It's going to be y equals x squared plus k. And Desmos gives me this option to add a slider, so I'm going to do that. And right now the slider is set at 1. I'd like to set the slider to 0, and you see that those two parabolas lie right on top of each other. However, as we move that slider, so as I make k larger, notice what happens to the parabola. Parabola is moving up, right? The vertex of the parabola is moving up. In fact, every single one of those points on the parabola is moving up. So I'm going to set it down to 3, and we'll take a look at this. Even though these two parabolas do not look perfectly identical right here on the screen, if I drag this down a little bit, it's only because we're not seeing as much of the blue parabola. So the red one, or the original parent function, got shifted up 3 units to become the new function, the blue one. In fact, every single point got shifted up as well. Notice how the old vertex of 0, 0 is now the new vertex of 0, 3. And I'll label that on the graph, okay? So that point got moved up. Notice that the point 1, 1 also got moved up. So now it's at the point 1, 4, and that point is on the new parabola, okay? I could do that with all the other points as well. I'm going to get rid of those points and go back to see what happens if k goes negative. So right now we're looking at a case that's like y equals x squared plus 3. If I drop k down, there it is at the origin. And if I go a little further as k goes negative, say I go down to like negative 2 or so, right? At negative 2, now our vertex has moved 2 units down, and the vertex is now at 0, negative 2. And in fact, every one of those points moved down as well, right? I could look at the vertex, 0, negative 2. That's now plotted. And I could also look at, say, 1, negative 1. That one's now plotted as well. So the way we get a parabola to move up or down on the graph is to either add or subtract the quantity at the very end of the function. Okay, that's how we move up or down. I'm going to start a fresh graph here, and I am going to take a look at what happens. How can we make the parabola move left and right? Okay, so I'm getting rid of everything but the parent function. The new function now that I'm going to graph is y equals x minus h squared. And I'm going to add a slider for h. I'm going to set it to be 0 just to start, okay? So right now what I did is I replaced x with x minus h, and we're going to see how the parabola moves left or right. Now notice this weird thing. It's x minus h, yet when h is positive, the parabola moves to the right. And when h is negative, the parabola moves to the left. But how is that going to appear if we were to actually write it as a function, right? Because suppose h was negative 4. Well, that's actually going to appear as x plus 4 quantity squared, right? So in order for the parabola to move 4 units to the left, we replace x with x plus 4. In order for the parabola to move 4 units to the right, and when I say the parabola, I mean every point on the parabola, including the vertex, we would replace x with x minus 4. Okay, so that one is weird because it's the opposite of what you see. When you see x minus 4 in the function, we've really moved 4 to the right, or in the positive direction. There's reasons for this that you'll learn about in Algebra 2. And if we move 4 units to the left, we're going to see x plus 4 inside the parentheses. Now, putting all this together is what we call vertex form of a parabola. So I'm going to show you those two ideas combined now. And I'm going to leave it as y equals x plus h squared, and then I'm going to put plus k on the end. I'm going to make both of those sliders, okay? So right now I'm going to set h to 0 and I'm going to set k to 0. As I make h larger, the parabola moves to the right, there it goes. And simultaneously, I could make k positive or negative and move the parabola up or down. So now we see where that parabola goes, where that vertex goes, and where every point on the parabola goes based on the adjustments that we have in there. So notice what it's going to look like in the function. It's going to be y equals x minus 6 squared minus 4. And now we see that vertex form. That vertex form showing the vertex is at 6, comma, negative 4. Here, I'll plot that point, 6, negative 4, and label it on the graph. That is the vertex. Okay, one last thing. We also have that a value that we learned about last time. So I'm going to put the a value back in here. And I'm going to show you that the a value can still affect the shape of the graph even in vertex form. Okay, so if I make a big, that parabola becomes narrower. And as I make a small, that parabola gets much wider. In fact, if I make a negative, the parabola opens downward. Okay, so what you see here that I'm about to highlight, that thing is called vertex form of a parabola. It reveals the a value, which tells us how wide or narrow the parabola is and whether it opens up or down. The h value tells us how far the parabola has moved either left or right. Remember that it's the opposite of what you see. And the k value tells us whether the parabola has moved up or down. And we're going to continue practicing those ideas for a few days. And we're also going to try and graph some parabolas coming up here as well. All right, thanks guys.